guess just to quickly describe my setup here. So I have a Raspberry Pi right in this case here. So it might be kind of difficult to see, but I have a Raspberry Pi 4 in here. It's connected to the monitor here, mouse, keyboard, and I also have a getting started kit connected to it. And then what I'm doing is I'm using VNC Viewer. So I have, if anyone wants to know about VNC Viewer, let me know. But essentially, I'm mirroring my desktop here. So like, for example, if I just drag this around, you can see it dragging around there. So I'm doing that so we can all see what I'm actually doing on the Raspberry Pi. So today, this is what the schedule is looking like. We're going to talk about Phidgets with the Raspberry Pi, of course. I want to talk about the options. So there are kind of some new options that are available now because we released browser-based coding support. So I just want to touch on that. If you do want to use the Raspberry Pi, but you don't want to code directly using Python. So we'll talk about your different options, and then we'll start off with a basic project. From there, we'll talk about different project ideas. So just kind of discussing what you can do with it, some options that are available. And then from there, we'll do a coding example. So we'll take one of those project ideas, we'll implement it. And then at the end, we'll do the sensor giveaways. So looking at options with the Raspberry Pi. So there's kind of two primary options now. We released Web USB support, as I mentioned. So Web USB sounds a bit confusing, but essentially what that means is you can code against your Phidgets through the browser. So that's an option for any computer that has access to a Chrome-based browser. So we'll talk about that. And then the other option is to write directly on your Raspberry Pi using something like Python. So the first kind of option there, this would be good if you're, bring up my Raspberry Pi here. So now we're on my Raspberry Pi screen just to keep everybody up to date. So this is a good option if maybe you have some Raspberry Pis laying around. Maybe you're in the middle school kind of age range, so you don't necessarily want to maybe get them going with Python directly, but you have some Pis laying around and you kind of just want them to start exploring. The first thing that you'll always do with Phidgets, with the Getting Started Kit, is go to phidgets.com/start. So if you ever give a student, if you have a Getting Started Kit and you ever want to give it to a student to try out, the first thing that you'll want to do is go to phidgets.com/start. So that's on the side of the box as well. So you'll always be able to see that. So essentially what that will do is it'll bring you to this page here. If you haven't seen the start page in a little bit, it's changed, as you can see. So now there's a few more options that you have. Scratch is going to be available soon. It'll be available in 2022. But right now your options are MakeCode and a desktop environment. So right now we're talking about MakeCode. So just like you would with any other computer, so a Mac or a Windows computer, you can use MakeCode with your Raspberry Pi. So if you haven't experienced Phidgets with MakeCode yet, essentially it just allows you to code against your devices through the browser, which is new and which is really, really nice. So basically what it looks like, I'll just reset this so it looks like you guys will see it. So it essentially looks like this. We have the full Getting Started Kit tutorials here. So for example, again, you say you have a Raspberry Pi, you want the student to start exploring the Pi, but you don't really want them to get too involved because maybe they're in middle school, maybe grade 7, 8, 9, maybe even 10. What you can do is give them the kit and you can start them on this path here. So this top row is the Getting Started Kit row. So they would start with the blink LED section. So they have the option between blocks, JavaScript and Python. So just choose blocks for now, for example. And then this will just function like it would on a Windows machine or a Mac or whatever they're using, a Chromebook, doesn't really matter. So essentially what they can do is they can follow the tutorials up here. So these tutorials are the exact same as the desktop ones. They're just made for MakeCode. So, in this one right here, they have the instructions here. So they're, for this first step, they want to turn the red LED on. So they're going to get their blocks from this little tray here. They can drag in their blocks, turn the LED on, and then go to the next step. So the point of this one is that they just blink their LEDs. So they go next, next, next. They get all their instructions. So we'll just quickly do this here. So we can turn this on, turn it off, and then we'll just pause again at the end. So essentially, this is how you can interact with it on the browser. The only thing to note here, if you haven't used MakeCode before, is when you go to this page, like if you're doing this right now, for example, if you're going to this page, this down here will not say device connected, it'll say connect device. So basically you would just click on that. I'll just actually show you here quickly. I'll just reset my permissions here and I'll reload. So if you're just going to this page right now, for example, you'll see this right here. It'll say connect device, and hopefully you guys can all see that. So you click on that, and then it will bring up an option menu right here, or like a little menu right here. And then you can just click on the hub and say connect, and that will pair your Phidgets to MakeCode. So then after that, you can press play. And if you have your Getting Started Kit connected, you'll see that Getting Started Kit start blinking. So that's kind of your first option with the Raspberry Pi. Again, it kind of depends what your goal is. If your goal is to just have the student exploring the Pi, maybe just getting used to it, that's a reasonable option. If you're at the high school level or older, what you're probably going to want to do is go into this desktop environment here. So if you've used Phidgets on a Windows machine or a Mac in the high school level, this is something that you'll be familiar with. So it's that Getting Started Kit tutorial. And what you'll want to do is just make sure that you have the Raspberry Pi selected. So again, you can select whatever operating system that you'd like. And you just want to make sure you have the Raspberry Pi selected. And the options right now are Python and Thonny. So Python and Thonny is something that comes pre-installed on your Raspberry Pi. So it's pretty nice. And you want to press done, and that will set up your environment for the Raspberry Pi and Thonny. And essentially what you'll see here, this is the part that's going to look slightly different compared to when you're on a Windows machine. So you're going to have this install step right here. So we'll open these two up. These are kind of like the two main components to the Phidgets with the Raspberry Pi. So the install step is just this kind of step you have to do to install the libraries on your Pi. So if we kind of dive into that, it looks something like this. So it says, if you're using a Raspberry Pi Model 2 and above, you have to open the terminal and enter the following commands. So basically, you can press this copy button right here, and that will copy the command there. And then what you're going to do is you're going to open up the terminal. So you can open up the terminal right up here in the top left. That'll pop up the terminal here. And essentially what you'll do is you'll just right click and press paste and then press enter. And that will install the Phidget libraries on your machine. So that's the first step there. And I already have them installed, so it'll just say everything is already kind of pre-installed. But this just takes a few seconds. So there you go. It's already the newest version. So that's the first step that students will do on the Raspberry Pi. And then the next step that they'll do, so that's basically this install step. The next step is the configure step. And this basically relates to the programming environment. So I mentioned that Thonny is kind of like the default Python environment for the Raspberry Pi. So you can get to it by going up here. So you can click on the little Raspberry Pi icon. And if you go to programming, you'll see that Python is the default, Thonny is the default Python editor. So you can click on that, and then basically the students who are doing this, they can follow the instructions. Let me just click on this. I think there we go. So they can essentially just follow these instructions here to set up Thonny to work with Phidgets. And again, this is pretty straightforward. So I'll do it here right now. It'll take a few seconds, but all they're going to do, it's the exact same thing on Windows. All they're doing is they're just going to Tools, Manage Packages, and they're just adding that Phidget package. So Phidget 22 like that. And then they're just installing Phidget 22. So they'll have a little button here that says install. They press that, and then they're good to go. They can start writing code. So if you want to get started with Phidgets on the Raspberry Pi, your two options again are MakeCode or Python. So it just depends on what you're kind of looking to accomplish. Python's obviously kind of like a little bit more advanced, but it gets them actually coding on the Raspberry Pi, which is quite nice. So the question in the chat was, can I use iPads? So you can't use iPads right now with Phidgets. It has to be Chromebooks or so basically Windows, Mac OS, Raspberry Pi, Linux, or Chromebooks. There's no support for iPads right now. Alrighty. So what I'll do now is I'll just show you basically a project. So if we're writing code against it. So we'll open up that Raspberry Pi again, which is in BNC. So say your students now have gone through this configure step. So all the instructions that I mentioned were in here. So they open up that package manager, they install Phidget 22, and then they're good to go. You can press finish. That will bring them back to that Getting Started Kit tutorial page. And then from there, what they're doing is they can kind of work through these tutorials again. So if they, if they haven't used Phidgets yet, they'll obviously work through all these tutorials. If they have used Phidgets, so say they've used Phidgets on a normal kind of like a Windows environment, I would just get them to go through this top row here so that they're configuring their Raspberry Pi correctly, because you do need to go through the install step and the configure step to make sure that you can actually write code on your Raspberry Pi. So definitely important to go through these two steps, even if they've used Phidgets in a different environment before. If they haven't used Phidgets, say the first time using Phidgets is with the Raspberry Pi, then they could continue on to these lessons here. So again, this is the Getting Started Kit lessons. If anyone has questions about the Getting Started Kit or what it means or what it is, let me know in the chat. But essentially, they could, if they haven't done it before, they can run through the first step here, which is the blink LED section. They have their code, and it works just the same as in any other operating system. So they can open up Thonny, they can create a new file, they can paste that code in, and they can run their file. So this will be blink LED. And then they have their LED that's blinking. So just like we saw with MakeCode, but now we're doing it from the Python environment. So that is how you would kind of write your first program. And again, if they haven't gone through this yet, they can just go through all the Getting Started Kit. So the question in the chat here is from Daniel. It says, can Phidgets work with Arduinos? So you cannot use like the hub. You basically can't use Phidgets with Arduinos. It needs to be something that has that's running either Windows, Mac, or Linux, or something that has a Chrome-based browser. So Chromebooks will work as well, but you won't be able to use them with Arduinos. Alrighty, so taking a look here. So what we did was we kind of explored these two options and how you would actually get started with those. So if anyone has questions about that, let me know. If not, we're going to take a look at some project ideas here, just to show you what people are actually using the Raspberry Pi for, and kind of what makes it really nice with Phidgets. So taking a look here, monitoring and logging applications are really, really common and really pretty awesome projects that you can do with Phidgets. These would probably be at a little bit of a higher level, probably high school, but I mean, if you do have advanced students in junior high or middle school, that could definitely work. But this is essentially when you're basically you have your Raspberry Pi, you're connecting a bunch of different sensors and you're using it to log information. So I think we had Christopher earlier in the chat was talking about how he wants to use his plant kit. So he has a Phidget plant kit, and he wants to use that with the Raspberry Pi. So that would be kind of like a logging application. So you'd have this thing sitting next to a plant with the plant sensor, the moisture sensor, and it would be logging information about the moisture of the plant. So that's a really common application, is any kind of monitoring or logging. We had a school that had a greenhouse on campus, and they basically set up temperature, humidity, barometric pressure. They had like a bunch of different sensors, and they were logging all that information, and then they actually made a website based on that, which was pretty cool. Another pretty interesting application is using the camera module. So there's this camera module that Raspberry Pi has. It looks like this. So hopefully you can see that. But essentially this plugs right into pretty much all of the Raspberry Pi boards, and you can really easily use it with Python, with your Python programs. That opens up a lot of different programming applications, which is pretty fun. So one that we had a student do was they used their Phidget rover kit. So they basically had a Raspberry Pi kind of controlling the rover, and then they had the camera module, and their goal was to kind of detect, I think that the thing was like driving towards the color red or something. So if you had like a red square, it would drive towards that. So you can use, there's a bunch of different computer vision modules that you can use really easily with the Raspberry Pi. So that's a really cool project as well. As I mentioned, hosting a website is super easy on the Raspberry Pi, and that's a really nice project. So if you missed it earlier, I was just showing everybody, this is an example of like a logging / website project that I have running at my house right now. So this is a Raspberry Pi is at my house, and basically there's a soil moisture sensor that's in a plant, and it's basically logging all that data and then displaying it on a website. And then I have this website available. So I'll put this in the chat. So anyone can access that. It's in the chat there. And this is essentially what that school did with the greenhouse. They had a website that was created, and anyone could go see the data broadcast from the greenhouse, which was pretty cool. Can a camera be connected to the Vint and or Raspberry Pi? Yeah, so the camera basically connects directly to the Raspberry Pi. So if you have your Raspberry Pi, there's a port on it. There's a ribbon cable that goes in right there. It's kind of tough to see, but essentially you would have that connected directly to the Pi, and then you actually can write a Python program that uses the camera to take pictures, and you could look at you could do some computer vision stuff with it. We have a project, so I'll show you guys where to see projects with Phidgets in the Raspberry Pi. So I'm going to phidgets.com, and I'm going to the projects tab. So there's 3 tabs: getting started, device tutorials, and projects. So if you click on the projects tab, you'll be brought to this page right here. And then what you can do, you can scroll down and you can click on this Raspberry Pi here. There's a little selector there for the Raspberry Pi, and this will bring up some projects that are already already pre-made for you. And we have one about cameras right here. So in this one, I'll show you the code, what it looks like. But this talks about how you can actually use the camera and Phidgets together. So the idea with this project is that when you push one of the buttons on the Getting Started kit, the Raspberry Pi takes a photo. So you can see the code here. Make that a little bit larger. But essentially, you can see here, this is the kind of part that's actually taking the photo. So if the button's pushed, all you have to do is say camera.capture if you're using that Raspberry Pi module, and it'll grab a picture, and here in this situation, it's saving it to the desktop. But it's actually really cool. And then, can we accomplish the same functions with webcams on Windows and Mac? Yeah, so you can accomplish a similar thing. The only thing that's a little bit nicer with this is that you have this nice API to use the camera. So it makes it slightly nicer when you're making these projects. But yeah, you can definitely do the same thing with webcams as well. Alrighty, so those are some different kind of projects, and I showed you guys the website. That's a really nice kind of level up thing to do after you've gone through the Getting Started kit. Maybe you've done a few projects. I think adding the Raspberry Pi and then making those monitoring projects and making the website stuff is like a really nice, if you have those students who are looking for a challenge, that's a really nice thing to do. So what we're going to do here is we have this coding example that we're going to go through. And the idea basically is to create this room monitoring system on the Raspberry Pi that is measuring temperature, humidity, light, and sound. So basically the idea is that you would collect all this data, you would log it to the Raspberry Pi, and then as an advanced kind of add-on, you could do these 2 things, which is running on boot and displaying via a website. So I'll talk about those when we get there. But I'm just going to show you how you would actually create a room monitoring project. So this would basically be kind of, part 1 to the website project. So if you wanted to get something like this website going, where you have data being collected and then you want to display it, this would be kind of part 1 of this project. So the first thing that I'm going to do, I'm going to go to the website, and what I'm going to do is I'm going to go to the device tutorial section, and I'm going to get my base code from the device tutorial section. So these tutorials are a really good way to get code for any sensor. So if you're like, if a student has a power plug or has a motion fidget and they want to just figure out how to get started with it, you're always going to want to go to this device tutorial page, and it will give you all the information that you need. So I'm going to scroll down until I see the humidity fidget. So here it is right there. Click on that, and then that will open up this tab here, which is some basic information about the humidity fidget. And again, this is the sensor that's on the back of your getting started kit. So it comes with every getting started kit, and essentially it allows you to measure both humidity and temperature. So it's a pretty cool sensor in terms of monitoring ambient conditions. So we scroll down, and then what I'm looking for is this base piece of code right here. So I'll copy this, and then what I'll do is I'll open up Thonny, and I'm going to create a new file. So file new, we'll create a new kind of script here, or new file, and I can paste in that code. And then essentially what we have is we have a project that is now taking data from a humidity sensor and a temperature sensor. From there, what I'm going to do is I'm going to take my light fidget. So this is what a light sensor looks like. You may have one in your classroom already, but essentially this allows you to monitor the amount of light in the environment that you're in. And all I'm going to do is I'm just going to plug this in. So I have a fidget cable here. So I'm just going to plug in my light sensor like that. And then I'm going to go inside my getting started kit, and I'm just going to pick an empty port on the hub to connect to. So right now I'm connecting to port 2. And then I'll put that on my desk here. So now I have a light sensor and I have the humidity fidget, which functions as a as a humidity and temperature sensor. So when you're adding fidgets to your projects, it's really, really easy to add them. All you have to do is just import classes. So again, you can, because I have that light sensor, I can go back to my device tutorials here, and I can find the light sensor page, and that will give me the code that I need. But I'm just going to write it because I know what I'm looking for. So essentially all that I'm doing is I'm just going to import the light sensor class because I'm using a light sensor. I'm going to create a light sensor object. So just like we have here, I'm just going to say this is a light sensor. I'll just copy it from here actually. So light sensor, and I'll name it light sensor. And then I'm going to open it. So again, if you've been to previous webinars, after the open call executes, that's what actually is bridging your physical fidget to your software object. So when it actually gets past this line of code, that means that they've made a connection, and you can use the sensor essentially. So after I call open, I now have access to the light sensor, and then all I have to do is just get data from it. So I can do something like this. I'll try to make this a bit smaller so that we can see. There we go. Hopefully everybody can still see that reasonably well. So what I'll say is I'll say light like that, and then I'll just say light sensor. And then the call for light sensor is get illuminance. And the units are in lux. So again, all of that information about the call and the units are all in that device tutorial page. So basically what I have now is a project that is interacting with a humidity sensor, a temperature sensor, and a light sensor. They're all plugged into my getting started kit, and they're all plugged into the hub. So again, the hub is that centerpiece. Looks like this. This is the one that comes inside of your getting started kit, and this is where you connect all of your sensors. So you're always going to have a hub. So essentially, if I press run on, I'm going to have to save this. So we'll save this quickly as monitoring.py. So we save that and we run it. And then what we're getting here is data from our sensors. So I didn't format it very well, but we can see here. Let me see if I can make that larger. So now we're getting humidity, temperature, and light values coming from our project here. So that's kind of the first step there is creating a base kind of program that can actually talk to the sensors. And then just taking a look at the comments here, can MakeCode be used in a Chrome browser on Android/iOS? So you can use MakeCode with an Android device. So if you had an Android phone, you could definitely do that. And essentially you would just connect you would need an adapter for the hub. So whatever USB, I think most Android devices are USB-C now, but you can connect directly to an Android device. So if you had like a phone, you could definitely do that. iOS is slightly different because Apple requires a certain chip that it's kind of a long story, but anyways, you can definitely do it on Android. iOS, you cannot do it. Not right now anyways. So going back to this, we now have a program that is interacting with those 3 sensors. It's on the Raspberry Pi, so we kind of have the first section of our project going. So taking a look back at what we wanted to do, we wanted to measure these the ambient conditions, so today I'm not going to do sound. We're just going to do temperature, humidity, and light. The next step here is logging information. So this is kind of a key step to actually displaying that information on a website, because you need to create this log of data. So what we actually have, again, we're going to go back to the website here. So we're going to go back to that projects tab that I went to earlier, and we're going to unselect the Raspberry Pi. So you're going to hold Shift if you're on the website. So holding Shift will let you select one object or one kind of filter. So I'm going to make sure everything is selected, and then I'm going to go up here. There's also these tabs up here. So I'm going to click Advanced, and then that will bring me to this page, or this will bring me to all the advanced projects. And what I'm looking for is we have a project that talks about logging sensor data. So I'm going to look for this one right here. It says logging sensor data to a file. And I'm going to open that up, and that will give us code that we need to actually take that sensor data and then store it in a file. And then this code here works with anything. So Windows, Mac, we're on Linux right now, but what we're going to do is just make sure that we have Python selected. So go back to that selection, Raspberry Pi, Python, Thonny, and there's our code right there. And then what I'm going to do is I'm just going to steal this code right here that is writing data to a file in CSV format. So I'm going to copy that, and I'm going to go back to our Raspberry Pi. And then what I'm going to do is I'm just going to paste this in here. And we're just going to take a look at what's actually happening. So we can see here that we're basically creating a file called Phidgets_temperature. Let's just change that to say Phidgets_monitoring.csv. If the file already exists, we're just going to append to it. That's what that A means. And essentially what we're doing is we're just writing the data that we're collecting from the sensors. So what we can do is we can probably make this a little bit nicer. So what we could do is say something like this. We could say humidity string is equal to this. So we'll take the raw value here of the humidity, and we'll just put it into a string, a different variable there. We'll say temperature string is equal to this here. Ooh, we can just copy that. So now we have a temperature string. And then we can say light string is equal to this. So now we have three strings that are easy to use. And then from there, what we can do is we can write them into our CSV. So if anyone isn't familiar with CSVs, let me know in the chat. You can also see a description down here. So what is a CSV and why do we use it? So it's a really easy way to get data into a file, especially when you're using sensor data. It's just a really nice way to do it. So basically what we'll do now is we'll just write the data. So we'll say hum string plus a comma, because this is a CSV, so it's a comma separated value or values. We'll say temp string plus a comma, and then we'll say light string. And then we'll do no comma, we'll just do a new line. So what we have now is humidity, comma, temperature, comma, light, and then we have a new line. So every time this runs, this loop here is running every 2 times a second. Every time that runs, it will print a new line in a CSV. So what we can do now is we can save that and run it. And then we should get this. It is running. We don't have any output now because we took away all of our print statements. We'll let it run for a few seconds and we'll stop it. And what we should see is a Phidgets_monitoring file was created. So this one right here. So Phidgets_monitoring. This was just created right now, it looks like. Yes. And we can open this. So we can try to open it in, you can open it in a spreadsheet software. That probably is what makes the most sense. So we can open it here, and then we should see some nice kind of columns of data. So there it is there. So there's all of our data that was printed to the file. So pretty cool. Really, really easy way to get all this data into a file. And that's kind of the first step in when you want to create a logging device, basically, because you need a program that is basically, monitoring something and then logging it to a file so that later you can analyze it, you could display it. If you had this running for a long time, you could create graphs in Excel. We had some students in a school who were trying to find the hottest and coldest part of their school. So they basically had a kind of something like this, and they were walking around the school, logging data, and then they kind of went back after, and they were using this to kind of, equals min, and they were getting the minimum, they were getting the maximum, and trying to see all that stuff. So it's a good way for them to also explore spreadsheets and all that. So that's how you would do that. The next step on that would be, and we can actually see it in that project we went to. Let's see if I still have it up here. No, I don't. So if we go back to that project, the next step to make that a little bit better would be to add a timestamp. So basically to time, let's go back there to show you what I mean here. So if we go back to that project, all of our projects always have practice problems at the end. So one of the practice problems here after learning about CSV is right here. So modify your program to log the time in another column. So you would log time in another column, and then when you finally display it, so we talked about displaying data on that website. So I'll just go back to that quickly. Let's see. So if we were talking about when we display it, so let's go to my plant again. The time is used so that you can obviously set your x-axis. So here you can see that my plant monitoring system has been running since January 27th. So that's what that extra column would give you, is the ability to sort them based on time. And again, basically all of this stuff. So, taking a look at this, so we were able to measure ambient conditions. We logged the information to a file. And then the next advanced type thing from there would be running the file on boot and displaying it via a website. Those would be two possible things you could do. And essentially what we have on the website, we have all those projects available. So if you, again, if we take a look at these projects here, Raspberry Pi, there are projects that allow you to do that. So start automatically. This project right here shows you how to automatically start a Python program when there's power supplied to the Raspberry Pi. So, the idea with these is that you don't need a monitor, you don't need a keyboard, you don't need a mouse hooked up. The idea is that you develop the code and then you schedule it to run when the device has power. So this project right here talks about that. And then there's a 3-part project right here that talks about making websites and displaying data. So again, if you're in a high school and you have any kind of greenhouse or even just a room, it's pretty interesting to see the data of a room. You could log sound, you could log light, you could log temperature, humidity, and they can explore that data afterwards and say, oh, look, when there's a bunch of people in the classroom, the humidity goes up. And it goes down when people leave, and there's all that type of stuff to explore, which is quite fun. And then Christopher said is talking about the Raspberry Pi Zero. So yeah, thanks for bringing that up, Christopher. So essentially, if you're using a Raspberry Pi that looks like these, so 3, 4, 400, you can use this install instruction. If you're using a different model, so if you're using anything lower, so lower than a Model 2, there actually used to be a Model 2, but it seems like they've removed it from their website. If you're using Model 1 or Raspberry Pi Zero, essentially from there, you're just going to say right here, using a different model. So there's a section right there using a different model, and you'll just follow these instructions. So it works on a Pi Zero as well, totally fine. The only thing to note is they've added this Raspberry Pi Pico. So this is the only thing that is slightly different. Because that is not actually running Linux. This is more of a microcontroller. So this would be more similar to like an Arduino. So you won't be able to use it with the Pico, but with every other device you will. You just have to look at the model number and make sure that you're following the right instructions. So that's kind of the only thing to make note of. It will not work on a Pico, but everything else it will. You just have to note the model number and then look to make sure you're actually using the right instructions. So hopefully that makes sense. If anyone has questions about that, let me know. But hopefully that makes sense. So that's what we had for the webinar today. I just wanted to do a kind of quick overview of how you install everything and how you would actually get started on it and some potential projects. That's kind of where we're going to stop today. We're going to be doing more webinars about the Raspberry Pi. and we're going to get into controlling motor controllers and things like that. But I wanted to keep it fairly straightforward today. I know it may have been a little bit advanced in certain areas, but if you have questions, let me know. Daniel's asking, will it not work with microbits? So you can't connect, for example, like you wouldn't be able to connect a sensor. So if you had like the pH sensor, the pH fidget, you can't connect that to a microbit. You have to connect it to a hub. So you have to connect to our hub, and then to a computer that's running Windows, Mac, or Linux or Chromebook. And then Christopher saying, yeah. So if you have a 0W, that's what this one is right here, Christopher. So yeah, you're fine to go with that. If you have any questions about that, let me know. But appreciate everybody stopping by, and we hope you have a good night.